Yeah, I'm Owen O'Reilly. I'm from St. Joseph's University, U City campus. And I was in Dr. Skierich's lab this year, Ola. And so what we were looking at is the effect of particular dipeptide, alanine isoleucine, on Arabidopsis seedlings and their germination and early growth stages. And the idea there was that we anticipated alanine isoleucine might have an effect on the germination of Arabidopsis, as it inhibits a very particular enzyme, you can see here, essential for the first step of gluconeogenesis, which is synthesis of sugar in germinating seedlings. It's very upregulated. So our anticipation was that if alanine isoleucine has an inhibitory effect on that enzyme, then it'll impact gluconeogenesis and cause a distinct change in the way that the seeds germinate. So we set up a nice automated phenotyping setup provided by Dr. Magdalena Jukolska. And we set up the individual seeds on little square plates in standard media for growth. And we just observed them for a couple of days. The automated phenotyping setup took pictures every hour. And we saw no impact on germination, which was extremely unexpected. Because, we expected this to inhibit that particular pathway and show any effect, honestly. What we did see, however, was there is a distinct effect on the root phenotype of the germinating seedling. So after 5 and 7 days, it became very apparent that their growth was either being delayed or stunted or something was happening to them. And you can see in these pictures in particular, there's a distinct difference between the standard media they're being grown in and then higher concentrations of the dipeptide. So this was intriguing to us because it wasn't an effect we expected, and it had replaced an effect that we did expect. So that was the majority of our research, was just confirming the effect and then also confirming that the constituent amino acids of the dipeptide didn't have any effect on germination. They'd actually augmented the growth. So it was the exact opposite and showed very much that the dipeptide was responsible for this effect. So now that about ended my project. We did a couple of replicate trials just to make sure that we were certain of this conclusion. And now future work is going to look into more exactly what effect the dipeptide is having through metabolomics assays, and whether it's specific to alanine isoleucine or whether there's other dipeptides that are also affecting this mystery pathway causing root growth stunting. Yeah, I'd say that's about it.
That is so fun, Owen. So you have this dipeptide, and can you tell the audience a little bit more, like how much of an effect overall do dipeptides have on plant biology? Do you know?
Yeah, so actually dipeptides are a relatively unexplored field. They're known to be byproducts of protein metabolism, so that provides some motivation for exploring like stimuli they might have, especially during plant stress and protein breakdown. But overall, their effects aren't super well known, which is why we're investigating this one.
So I can see that having kind of a really important, practical application, because dipeptides seem relatively easy to synthesize. And then if they have that kind of effect, especially early on in these pathways. So what was something about your project that you just really loved? What was something you got to have a lot of fun with this summer?
Yeah, so honestly, and it's a little bit off of what the actual project was, but the automated phenotyping setup was absolutely a blast to work with. I really enjoyed it. It was a very cool application that I didn't really see coming. So being able to see track through the pictures that it take, the growth of the seedlings, and being able to see almost a time lapse of that was very nice. And also just working with plants. I've never done that before. So it was an amazing experience.